The map file is a tab-delimited text file containing the results of various characterizations performed on a single sample surface. This text file can also be dragged into Microsoft Excel for better visualization of the data. At the start, a blank map file is always created and contains 5 characterizations under the mapping category. These are labeled as pixel X, pixel Y, point ID, point type, and subsurface ID. A map file generally contains several columns or characterizations, each with the same number of rows. In each column, the very first row indicates the date and time when the characterization was performed. The next row entry is the software, protocol, or notes for the selected column or characterization. This cell contains information about the method used for characterization. This field can be automatically filled by a software generating the map result files, for example, ArthroBST, Mach1 Analysis, or Mapping Toolbox. The next row entry is a validation code for the selected characterization. Once again, this field is automatically filled by the software that generates the map result files. It ensures that the characterization results have not been modified following creation by the software. This field can also be left empty or be filled with NA. The next row entry is the template used for the selected characterization. This is a reference to the surface positioning template, also a map file, which is used to recognize the characterization. Note that the template file must be present in the results folder if not integrated into the Mapping Toolbox software. This field can also be left empty if no surface positioning template has been used. The next row entry is the image used for the selected characterization. This is a reference to the image related to the characterization. This image must also be present in the same results folder and must have a resolution of 1280 by 960 pixels and a JPEG format. This field can also be left empty. The next row entry is the category of the characterization. The software uses the name of the category for some advanced functions and to group related characterizations. As you can see, the category for the first 5 columns is mapping, with uppercase letters. The next row entry is the name of the characterization and units. Any format can be used for this name, however, it is highly recommended to use standardized name using the following format. The first 5 characterizations are pixel X, pixel Y, point ID, point type, and subsurface ID. A few examples of other characterization names include scan X, scan Y, thickness, and Young's modulus. The next series of rows contain the stored data. These can be a value, text string, or file name depending on the characterization. When a file name is used, the corresponding file must be in the same result folder. Now let's take a look at the default characterizations generated by the software in more detail. Pixel X is an integer corresponding to the horizontal pixel location of a point in the image. The integer starts from 0 to the maximum number of horizontal pixels in the image imported by the user, -1. Similarly, pixel Y corresponds to the vertical pixel location of a point in the image. Point ID is an integer starting from 1 and corresponds to the ID of a point. For references 1 and 2, the point ID is a text string with the format shown. Point type is an integer from 0 to 2 and corresponds to the type of point. For example, 0 corresponds to position, 1 corresponds to boundary, and 2 corresponds to reference. Subsurface ID is an integer or text string corresponding to the name of a subsurface of the sample. For type 2 points or references, the subsurface ID cells are left empty. So let's take a look at a quick example to show how to interpret a dataset in a map file. As you can see, all characterizations acquired are shown for all positions as point type is equal to 0. These are located on each subsurface, in this case the lateral and medial condyles. The first category shows mapping results such as the metric coordinates of these points. On the top, we can see they were obtained using the Mapping Toolbox software. The second category shows needle penetration results and were obtained using the automated indentation and thickness batch analysis software. The indentation category shows instantaneous modulus values, also obtained from the automated software. And lastly, in these two categories, the protocol or study number is also shown at the top.